there is a way to do this. I want to break this number 273 into prime numbers. Now, if you really needed to ever do this, you just get on your phone or something, you go to Google and you type in, or you say, get the prime factors of 273, and it'll give them to you. But let's see how to actually do this. So here's a mathematical way of doing this. It's a repeated division. Take this number here, 273, and take a look at the first prime number that you think will divide it. Now, here's what I'm thinking. It ends in a 3, so it's not even. Now, the prime numbers, by the way, go like this. They are 2, it's the only even prime. 3, okay, 5's not prime. No other even number's prime. 2, 3, 7, 9 doesn't work. 11, 13, and so on. All right, so start with the first prime number. Now, does 2 go into this number? Does it divide evenly? No, because it ends in a 3. So 2 doesn't work. What about the next number, 3? Does 3 divide evenly into this number? Well, you know, it turns out it does. And here's how I know that. If I add these digits, if I do this, 2 plus 7 plus 3, I get 12. And 12 is divisible by 3. So if the sum of the digits of the number 12 in this case is divisible by 3, the whole number is divisible by 3. So let's see what we get here. So we'll get 3 into 273. Now 3 into 27 is 9, 3 into 3 is once. So here's what I have so far. 273 is equal to 3 times 91. Now let's see if we can break down the 91. So we'll get 3 times something. Let's see. Now, 91. Does 2, go all the way back to the beginning, start the process over. Does 2, the first prime, divide evenly into 91? No, 91 is odd, so 2 does not go into it. What about 3? Does 3 divide into 91? No, it does not, because 9 plus 1 is 10, and this is not divisible by 3. All right, so 2 doesn't work, 3 doesn't work. What about 7? Well, I don't know. We'll just have to try it. Does 7 go into 91? Well, 7 to 9 is 1. That's a 7. Subtract 2. Oh, it does. Right, 21, we get 13. Okay, so I get 7 and the 13. So 7 and 13. Now, 13 is prime, so we're done. So what we're saying is 273 as a product of primes is 3 times 7 times 13. So I'm going to write that up here in our box up here. It's 3, 7, and 13. Here in problem 15, we are going to reduce this fraction to its lowest terms. Now, by lowest terms, I mean this. I'll do it at the top right here. Suppose we have this fraction here, 10 over 15. Now, you may recognize that as not being reduced. I could divide each one of these by 5. So if I do this, 10 divided by 5 and 15 divided by 5, I get 2 over 3. Now, both 2 and 3 are prime numbers. I can't reduce those anymore. So 10 over 15 is reduced to lowest terms as 2/3. So let's start here. We're going to have this number here. We're going to have 750. Oh, let's do it all in white. Okay, so let's see. 750 over 2058. All right, what are we going to get here? Well, look at the 750. 750. This is equal to, now, how do we do this? Here's our primes, right? I'll write them right here. 2, 3, 5, 7, 11, 13, so on. All right, now, does 2, start at the bottom, does 2 divide into 750? Well, it sure does, right? Because the number ends in 0. So 2 into 750, let's do it. What's that? 2 into 750. 2 into 7 will go 3 times. That'll give us a 6, a 1. Bring that down. Okay, now I know that 2 goes into 150 75 times. So right now I have these two numbers. So this is equal to 2 times 3, 75. So far, so good. Now, what about the 375? Well, let's start at the beginning. Does 2 divide evenly into 375? No, that's a 5. It's an odd number. 2 does not go in evenly. Does 3 go in? Well, let's see. 3 and 7 is 10, and 5 is 15. If I add those numbers, if I add these numbers, 3 plus 7 plus 5, I get 15. And sure enough, 15 is divisible by 3. All right? So this whole number is divisible by 3. So 3 into 375, 3 will go into 3 once. Now I know that 3 goes into 75 25 times. So now we've got 2 times those two numbers, 3 times 125. Now we have 2 times 3 times, what about this 125? Can we do anything with that? Well, we sure can. Because, all right, well, first of all, 2 does not divide into 125. 125 is odd. 3, that 3 does not divide because what do you get? 1 plus 2 is 3, plus 5 is 8, not divisible by 3. But the number ends in a 5, so the whole number is divisible by 5. So we'll get 5 into 125. Now, 5 won't go into 1, but 5 will go into 12 twice. That'll give us a 10. Bring down, there we go, 5 times 25. All right, so we get a 5 times 25. Now, 25 I know is 5 times 5, so I get this. I'm going to get 2 times 3 times 5 times 25, all right, is 5 times 5. But now this right here, I'm going to write this like this. I'm going to use exponents. 2 times 3 times 5 cubed. Okay, so 750, I'll do it up here at the top left, is 2 times 3 times, oh, let's just leave it like this. 5 times 5 times 5. I've got it completely broken down. Now this denominator, that 2058, well, first of all, it's divisible by 2, right? So 2, because it's even, right? So 2 into 2058, 2 will go into 2 once, into 0 0 times, into 2 into 5 will go twice. That'll give us a 4. Subtract and bring down 9. Okay, so now I've got this. That 2058 is at least equal to 2 times, right, those two numbers, 1029. Now, what about the 1029? Well, it's odd, so it's not divisible by 2, but if I add those numbers, I'll do it right here, 1 plus 0 plus 2 plus 9, I get 12. 12 is divisible by 3, so 1029 is divisible by 3. So 3 into 1029, well, 3 will go into 10 3 times. That's a 9 when I multiply. Subtract, and then bring down. Now, 3 will go into 12 4 times. 3 will go into 9 3 times. So I get 343. So there's 2 more factors. So now we're going to get 2 times, and that 1029 is 3 times 343. Now, this is 2 times 3. What about this 343? Well, let's see. 343. If I add them, I get 7 and 10, so it's not divisible by 3. So the next prime number is 5. Now, the number does not end in a 0 or a 5, so it's not divisible by 5. So I go up to 7. 343. Now I'm going to try it right over here. 7 into 343. Well, 7 into 34 will go, 4 times. That'll give us a 28, and that's a 6. Oh, good. Okay, 7 into 63 will go 9 times. So now I've got these two numbers, times 7 times 49. Oh, and the 49, we know that one. 2 times 3 times 7. 49 is 7 times 7. Okay, so let's get some room here. I'm going to erase some of this stuff that we don't need. And I'm going to say now that this denominator, that denominator up here, that 2058 is equal to this product of primes, 2, 3, and then 3 7s. So we're going to get 2, 3, 7, 7, 7. Now, let's cancel any common factors. So look what we've got. The 2's common, we'll cancel that. Actually, when I say cancel, I mean divide out. But we just say cancel. The 3 is common. Let's divide that one out. So what's left? What's left is 5 times 5 times 5 over 7 times 7 times 7. Now I'm going to write this like this. You could leave it like that, but how about 5 cubed over 7 cubed? We'll claim that that's our answer. So I'm going to write that up here. So I'm going to write it as 5 cubed over 7 cubed. You know, but rather than writing 5 cubed over 7 cubed, if you just multiply these out, 5 times 5 times 5 is 125, because I'm thinking this is how the textbook is going to want it, or the answer should be like this. 7 times 7 is 49, times 7 again is 343. I think that's the way we would probably have to write this answer. So let's do it that way. So this is going to be 125 over 343. That should be it.